Hi everyone, it's Mr. Hamilton here. Welcome to this lesson on operations with radicals. Now a radical is something you've seen before. It's a square root, but we can have radicals that are in a number of different forms and look different in different equations. And so we're going to have a whole bunch of goals that might not make sense now, but as you go back to the end of the lesson and look back at these goals, you should be able to understand what these mean and know if you know them or not. So the first goal is to identify what a radical, mixed radical, and entire radical are. Then we want to reduce and simplify a single radical. We want to multiply mixed and entire radicals using the distributive property for polynomials, and then we want to add and subtract polynomials. Our ultimate goal is in light of this lesson that we're going to have tomorrow on the quadratic formula. You've probably heard of the quadratic formula before, and if you've ever watched a show that has any mathematicians in it, for example CSI or something like that, it would have this equation at some point: x equals negative b plus minus the square root of b squared minus 4ac over 2a. Hold up a second. That seems like a huge equation in terms of what you've seen before. And so that might be overwhelming. And what I want to just reassure you of is that we're going to look at this step by step so that by the time we get to this, and we're going to actually see it's easier than we might think tomorrow, we're going to be comfortable using this. So bear with me. We're going to get through this. We're going to understand this. Here's what it might give you. It might give you an answer like 4 plus or minus root 8 divided by 2. And we're going to want to simplify to an exact answer, and the exact answer in this case would be 2 plus or minus root 2. And so my hope for today is that we can be able to go from here to here by the end of the lesson. So let's talk about radicals. A radical is a square, cube, or higher root. So if it's squared, it's a square root. But we could also have a cubed root of something. So we could have a cubed root of any number, really. It might not end up being a whole number, but it just means some number times itself 3 times gives you 3. And we could have the fourth root of something as well. Let's go the fourth root of 625. That means that if you take some number and multiply by itself 4 times, it would give us 625. All right, the radical symbol is just this. That is what anytime we see a radical, that's what we have. And then if we put a 3 in front of that, notice it's not a big 3, it's just a little 3, or a little 4, that would mean the third root of the fourth root. An entire radical is a radical with coefficient 1. So for example, something like the square root of 25. There's no number in front of that. We could put a 1 there, but there is no number in front of that. A mixed radical is something like this. We might have 2 root 8. And 2 root 8, you have a whole number, and then you have a square root. All right, let's go through a little bit of investigation to see what we can do with these radicals. If I gave you the square root 4 times the square root of 4, you would say, well, that's 2 times 2. Well, 2 times 2 is 4. If I gave you the square root of 81 times the square root of 81, you can pause the video and do these yourself, just to check mentally if you can do them. That's 9 times 9, it's 81. Root 225 times root 225 is 15 times 15, which is 225. I hope you're seeing a pattern here. Root 25 times root 4 is 5 times root 4 is 2, which gives me 10. All right, so now what I'm going to do is, instead of separating the radicals between the two numbers, I'm going to put both numbers under the radical. So let's go root 4 times 4. So what we're doing here is root 16. The square root of 16 is 4. And then the next one is 81 times 81. So we're going to go with the square root of 81 times 81 is 6,561, which is 81. The square root of 225 times 225 is the square root of 50,625, which is 225. And then the last one, square root of 25 times 4, is equal to the square root of 100, which is 10. What do you notice about the result in each row? Well, hopefully you see that it's the same answer. Right? If we compare each of these, this to this, and this to this, all the way down, you can see that those give you the same answer. Well, that's all well and good. Well, what does that mean? That means that if I take the square root of a number and I multiply it, notice it's multiplied, that's important. If I multiply it by the square root of another number, that's the same thing as multiplying those numbers ahead of time and then taking the square root of them. And so that's our first property of radicals. Square root a times the square root of b equals the square root of a times b, just as we saw in that little investigation in the chart up above. A second property of radicals that we're going to use quite a bit is this. if I have some number, c is some number, notice it's not like a third root or fourth root, it's actually a big number out in front, times a radical, root a, and I multiply that times another number times another number under the radical. What I do is I multiply the numbers in front, the whole numbers in front together, and I multiply the numbers under the square root together. So what I'm left with is c times d times the square root of a times b. So these two properties are going to be really important as we work through this. So let's talk about reducing and simplifying a radical. Well, what does that even mean? It just means to make it simpler so that something we can more easily see. Now, it might not be super clear for something like a here, but for b and c, that's a pretty big number under the square root. We want to get it as small as possible. So what we want to do is find the largest perfect square that's a factor of the number under the radical sign. And so in this first case, the largest perfect square, well, that's equal to the square root of 4 times 2. That's a perfect square. That's the largest perfect square I can find. Next perfect square would be 9 and 16. In fact, let's write these out here, perfect squares, just so we have reference to them throughout this lesson. Perfect squares, we have 1 squared is 1, 2 squared is 4, 3 squared is 9, etc. So you can go ahead, if you want, you could pause the video and keep doing that. I'm going to pause it here and complete the list now myself. So I've gone all the way up to 15 squared, which is 225. And so it's good to be familiar with all of those, have those handy to remember. If you don't have those memorized very well, review them on a regular basis so that you do. Well, let's go back to this particular question. We have square root of 4 times 2. And so now we want to write the number under the radical as a product of the perfect square. And so what that means is I'm going to write this as root 4 times root 2. So I've written it as the product of the perfect square, so I've got 4 in there. Now I'm separating those two using that first property that I used above. And now we want to reduce the perfect square radical. So well, root 4 is 2, and then we're left with root 2. So we have 2 root 2. That is what root 8 is. Now that's a lot easier for us to get our heads around, and that's still not something that you might know off the top of your head because you're like, well, what's root 2? Well, it's 1.41 something, right? But in terms of exact answers, that's very useful for us, and the more accurate we can be, the more exact we can be, the better we're going to be at getting accurate answers. So it's important for us to be able to do this. Let's look at root 50. Root 50 is the same thing as, if you think about this, well, 1, that's useless to us, really. 4 goes into 50, nope. 9, nope. 16, nope. 25 does. And in fact, if you think about that, that's just root 25 times 2. Well, the root 25 we know is 5. And so that becomes 5 root 2. And as a mixed radical, that's what we get. Now, root 180. Okay, well, let's find the largest perfect square that we can possibly get here. And so 1's not useful. 4 goes into it, but let's see if we can get even bigger than that. 9. Okay, 9 works. 16, nope. 25, 36. Here's the deal. Let's say we tried 9. Let's go ahead and try 9. Let's go. This is the same thing as 9 times 20. Well, you'll notice that we still have a 20 there. This is the same thing as root 9 times root 20. Root 9 is 3. Well, we can separate 20. Well, we know 20 is 4 times 5, right? Well, that's 3 times root 4 times root 5. Well, that's 3 times 2 times root 5, and 3 times 2, we can multiply those together because those are whole numbers, is 6 root 5. Well, that all seems like it works, right? But we didn't necessarily find the biggest perfect square. So if you don't, you can still work with it. But if you had seen the biggest perfect square for this one, it actually was 36. And so we could have gone 36 times 5, and that would have given us 6. Well, actually, I'm getting ahead of myself here. If you're comfortable just going from this step down to the answer, that's fine. But represented here using the property above is root 36 times root 5, which gives me 6 root 5. And that's the same answer. So whether you take the largest perfect square or you take a smaller one and work your way through it like I did in the first time I did it, they're both going to give you the same answer. So you can do that as well. So that's how to reduce or simplify a radical. Let's go ahead and multiply some radicals together now. The strategy that we're going to use is when multiplying, we multiply the coefficients together and multiply the radicals together, so that we're using that second property. Then we try to simplify the radical if possible. So 2 root 3 times 3 root 6. We're going to multiply these numbers together, and we're going to multiply these numbers together under the square root. So you can do this in your head, but just for the sake of this first example, I'm going to show you this fully drawn. So 2 times 3, and then under the square root, we're going to have 3 times 6. It's going to give me 6 root 18. Well, root 18 isn't simplified as much as possible. Just to give you a bit of a hint there, we want to get it to be a prime number. That's one thing. But in order to, we're usually going to see root 2 or root 3 or root 5 or root 7. But most times we're going to see something that or smaller. Nothing bigger than that. And so if we do this, we have to recognize that root 18 is 9 times 2. Well, root 9 is 3. So this is, and then we're going to have root 2 left over. 6 times 3 is 18, and we get an answer of 18 root 2. Now go ahead and pause this and try to do the next ones and see what you get. The next one here is we're going to expand this by the first term and this by the second term. And so we're going to get 2 times 4, and we're going to be left with that root 3. And then we're going to go 2 times 5, and then root 3 times root 3. So that's root 3 times 3 under the square root. 2 times 4 is 8. 2 times 5 is 10. And then we're left with root 9 over here. Well, you'd be tempted maybe to keep root 9, but we should recognize it's a perfect square. And so this is going to simplify to 8 root 3 plus 10 times root 9 is 3. And so this is going to give us 8 root 3 plus 30. These are not like radicals, as we'll figure out very shortly, and so we cannot simplify any further. That is the final answer. The only time we could add them together is if we had the same radical in both terms. This is one term here, this is another term. So if it had said 30 times root 3, then we could add the 30 and the 8, but in this case we can't. All right, so now we're going to FOIL this out. We're going to multiply this times this first. So 2 times 2 times 2 times root 2 times 2. And then first outside, we're going to multiply that now. So 2 root 2 times negative 3 root 3. So minus 2 times 3. And then root 2 times 3 under the square root. And then we're going to add the inside here. 3 root 3 times 2 root 2. So this is 3 times 2 root 3 times 2. And then we're going to do the last. First, outside, inside, last. And so we're going to go 3 times 3, and this is negative. So 3 times 3 times root 3 times 3. Just trying to get it in there in the screen for you. So that gives me 2 times 2 is 4. Root 2 times 2 is root 4. And then over here we have 6 times root 6 plus 3 times 2 is 6. Root 6. So those are going to cancel out if we subtract it and add it. And then root minus 3 times 3 gives me 9. And then root 3 times 3 was root 9. And what this gives me is 4 times 2 minus 9 times root 9 is 3. So this is going to give me 8 minus 27, which is going to give me a total of negative 19. And that works out really nicely. So watch for those kind of things. You think it looks really ugly at first, but the answer ends up being really nice. All right, so in the next video, we'll pick up on how to add and subtract radicals.